they feel attached to certain things. Like, for instance, I hear a lot about methane. Well, methane's a very strong greenhouse gas. It's even stronger than CO2. It's just there's less of it as a forcing factor.
Yeah.
But if you change methane and you said, well, listen, we can't control CO2, but we can control methane. Well, that's not really going to change global warming. So that's a concept that's really hard to convey. When we make a change, is this a change that's so reactive? If we then changed our minds and we did something new, we all would be well? Well, that's our point. Our point is, and it's not doom and gloom, but our point is we're really in a pickle when it comes to things like our fossil fuel consumption and CO2. It's a dangerous, dangerous world we live in.
It's not doom and gloom. I'll repeat that one. It's important. People should not lose heart. But what we should be doing, and first I'll assert something and then I'll ask you to confirm it or come up with your own. What I feel we should be doing is coming up with any way possible of sucking the carbon dioxide out, because that's the forcing that we could potentially control. There are something called advanced weathering techniques, where if you grind up a salt rock and you use it on fields, use it in farming, that it will absorb CO2. It'll become a CO2 sponge and will be burying, sequestering that CO2 in the soil. There are other techniques. Friend Dr. Peter Wadhams, who you probably know of,
I know.
he is pushing as hard as he can for humanity to explore the any means possible of sequestering carbon, taking it out of the air. And there are some promising technologies, but since they are cost and not a profit, you don't want to get, there's no one with enough vision to invest the money in saving humanity.
Correct.
So,
well, there are some, but the money is limited for the scale of the problem.
yeah.
And that's another thing. You can look at what we do today, but unless you understand the concept of cumulative effect, what we do today only impacts what we do today. We have to then go backwards in time, because the CO2, it's still up in the sky and in the oceans. And if you make changes through getting more CO2 into the soils, that's probably one of the bigger ones, or adding more forest cover, that's another big one. You're going to get an outgassing of the CO2 from the oceans back into the atmosphere. And so that's where the cumulative effect really, people have to understand, it's not what we do today, it's what we've done and what we will do. This cumulative effect is something that is quite large. And I think what you're saying is that we need to start working on it now. And then if we started working on it now, all the positive things would be another cumulative effect that would then affect the original cumulative effect of our negative consequences.
At least we'd be moving in the right direction,
We'd be moving in the right direction, absolutely.
and we'd be thinking in the right direction.
Correct.
Okay. From my perspective, and I work it into every conversation I have, the problem, as I see it, lies with a defective economic system where financial wealth and the accumulation of financial wealth is the only good or the principal good. And unless it produces wealth for someone, humanity's not willing to invest in it, even to save its children.
There are three things that our paper conveys that are really important. Population. We can talk about that.
Please.
Human population, human energy consumption, and human productivity. All three affect the Earth systems. And right now, they track each other as if they're exactly the same. So that, yes, people write papers. There are whole fields in economics that look at small perturbations off of this connectivity, so that you might have, we still have a growing population. We add about, I forget what the latest numbers are, 74 million people per year. So, you know, that's, I don't know, that's 140 Denvers a year, I guess we add on Earth every year, another 140 Denvers.
Mm.
So you can talk about population, and recently with the COVID, our CO2 use has gone down. So this is a perturbation. But if you, and we've had all sorts of recessions and things like that, they have little wobbles around their lines, but human population, productivity, and energy consumption, they're almost a perfect relationship. There's the Spearman rank coefficient is 1.
Okay, now that coefficient calculates statistically how well they track one another.
How well they track one another. And so,
and by the coefficient being 1, it means close to certainty. That is, they are locked together for all intents and purposes.
So, you know, people are saying, well, let's figure out, you know, get new energy supplies from the sun or from wind or things like that, renewables, in other words. But you haven't got rid of the people. You've got these 3 things. You're only affecting one of them. So you're assuming that your economics are not going to change. You're just replacing one energy form with another energy form. And that's a huge assumption, because the productivity is what our footprint really is from. You know, dams and making sure rivers don't flow as they should by nature, but flow according to what engineers and our human desires want. Things like that.
In Hawaii, we have a problem with them wanting to put a solar panel field on several hundred acres of prime farmland.
And so all I'm saying is that these 3 things cannot be decoupled. Right now, if they can be decoupled, that would be fabulous, because then you would have possibilities. But right now, when you're adding 74 million people a year, and you still have an incredible growth rate in human population compared to anything in the Holocene. Anything. It's never been as high, even now. So the highest was in the 1960s, but it doesn't matter. It's still really high now.
Yeah.
And so I think that if you want to talk about sustainability, you have to talk about population. And when I was chair of the International Geosphere Biosphere Program, you know, with 10,000 plus scientists who are working together to figure all this out on the human footprint, No one wanted to talk about population. And
it's a sacred cow. I was at the
terrible.
I went to the climate talks in Madrid, supposed to have been in Chile, but they moved them to Madrid because of rioting in Chile. And I did a program, a half-hour program on overpopulation. And I can assert with certainty that we were the only event in the entire COP, in the entire Conference of Parties, that dealt openly with the subject of population and the value judgment that we are in overpopulation, a state of overpopulation of the planet. But it's a sacred cow. You can't talk about it because of past abuses and perceptions and what's going to, and coercive population control tech. We've got to talk about it. We've got to pull the covers off of the elephant in the room. Yeah. Have you got any ideas for how we breach that forbidden subject, overpopulation or population, instead of making a value judgment on the front? How do we convince?
It's close to impossible to separate them. That's what we've concluded. It's close to impossible because part of productivity comes out in human health. So we improve human health. So we're living longer. Well, that also affects. So we now have, I think, 50% of all humans who've ever lived on the planet Earth have been alive, are alive today. In other words, we have an enormous mass. It's not just that we've had the Holocene, the last 11,700 years, averaged a human population of like 94 million people. And so this big acceleration hits. And that big acceleration of having humans put more of their energy into things other than surviving. So into productivity and things like that. That's this great acceleration. So you've got, and then that all this human productivity is then making us stay alive longer and longer and longer and longer. So our footprint, our human footprint, is expanding two ways. One, we're having more people, but it's also we're on the earth longer, consuming energy and products. So I think that, yes, we have to talk about this. And that's why I would like the topic no longer to just be, let's change it from a global warming story. In other words, getting renewables to replace CO2. That's existential. You have to do that. But if you did that, you still have a huge problem on your hand. You still have all these humans that by the time you solve it, we will be at 10 billion people. Let's say 2050 happens. Now you have 10 billion people. And let's say you cut your energy down. You may cut it down to where it is today. So 2050 is back to 2020. But you have another few billion people all spending energy. And so everything is coupled. And we need to worry about capitalism per se too, because capitalism means that it basically says we have so much excess energy from tapping all these geological sources, deep underground. We have all this energy. Let's then use it to have fun. Let's use it to make islands. Let's use it to do this, do that, you name it. We have 1 billion cars. Well, that's okay. We've got lots of money. And the roads. Well, we now have millions of kilometers of roads. Each of these kilometers of roads takes, I think I forget, I don't have these numbers in my head, but it's around 1,250 tons of sand and about not quite double that in gravel for every mile of roadway. Well, that's incredible. And we just keep building roads. And so now we're running out of sand. I mean, can you believe we're running out of sand for making asphalt and concrete?
You called it capitalism. I call it growth economics. I specifically avoid the word capitalism.
Oh, okay, fine.
So, no,
that's fine.
When it comes down to it, it's capitalism because,
yes.
as a philosopher once said, the problem with capitalism is capitalism. It seeks to grow. It always seeks to expand.
It seeks to grow. It
Yeah.
seeks to grow. And I think it's these growths in our curves that is most worrying. And one person wrote a paper and he was arguing about, well, maybe, you know, are things really accelerating? And he looked at a couple of things, and in certain, you know, we can hit limits. In other words, once you dam all the rivers of the world, you've dammed the rivers of the world.
Mm-hmm.
You can't dam anymore. And so you can hit a limit. And so he's saying, well, yeah, well, that isn't accelerating anymore. And I'm thinking, when you've dammed every river of the world, it doesn't matter that it's not accelerating. The impact, okay, here's a little stat. The reservoirs that we have are largely in place since 1950. Like 97.5% of the reservoir capacity on Earth is been put in place since 1950. So we build a lot of dams, and they trap, they do a lot of things. And a lot of it's good. I'm not saying there's your good, you know, it provides energy, drinking water supply, recreation, any number of things. So I'm not taking away from any of that. But it does a couple of other negative things. And one of them is it changes rivers from breathing like the planet wants it to. So we send water down rivers, not like they used to be. They used to have a flood season and a dry season, most rivers of the world, but now they don't have that. They're gauged and monitored, and so the water is kind of steady. All the flood curves disappear. So that's an example affecting the ecosystem. But another problem is they trap sediment that should be now going to these deltas. So the deltas are, the coastline's retreating rapidly. Well, that's because you trap the sediment in the reservoir. You trap so much sediment in these reservoirs that it could cover the entire state of California in 15 feet of sediment, 5 meters of sediment. All of Spain, 5 meters of sediment. So we are changing things, and I don't think anyone who builds a dam likes the idea that the dams trap sediment. They don't, because it decreases their reservoir capacity, and because it decreases that, they either when the water levels go down, they have to go in there and take all that sediment out. That's very costly.
Yeah.
Or they gotta really kill the dam and build a new one.
Yeah.
And so, in other words, release all that sediment, and hardly anyone's doing that, but that's a possibility. So no one thinks long-term on the state of the planet. And we're caught up in local stories, like the Americans now caught up in America's election story. Like, to a planet, it's just like COVID. To a planet, nobody cares about that. And so it's almost noise, background noise to the problems we have on our planet.
I'm going to sum up our conversation. I've got another one at the top of the hour, but I want to sum it up in a couple of ways. One, the problem is huge and it's not getting any better.
Correct.
The human footprint is growing larger exponentially.
Yes.
And the low-hanging fruit would be to control human population. And you raise your eyebrows, and I know.
Yes. Yes, and
Yeah.
that's the lowest hanging fruit. If you were to do that, and while you're increasing renewables, you're taking two of the three curves and moving them both down.
Okay.
And as long as you were wisely using your maintained productivity so that you took into account what the human footprint was from that productivity, then we would be moving towards a sustainable planet. And it's doable, but it will take the entire human population. It won't take intellectuals. It won't take uh, people from universities around the world to talk to each other. It will take the entire human population to understand the scale of the problem and what we can do about it. And let's get going on it. And hopefully all the dictators of the world will leave us alone while we try to save the planet.
I want to thank you, Jaya. Thank you very much.